So in this video, we're going to look at composite functions. This video is split into 4 parts. We're going to start off by looking at simple functions. So how do you answer questions when you're asked to find things like this? We are then going to move on to composite functions when a function has an input of a function. And then we are going to move on to proof. Well, how do you answer questions like this? And then finally, we're going to look at, well, how do you answer questions like this where you're asked to solve using composite functions? And as always, we are going to wrap up by looking at a real exam question. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and I've got the example on the right, which is you do. So the first question is asking us, given the function, work out the values. So we've been given a function here, f of x is equal to x plus 1, and we've been given 2 questions. So well, what this is saying is whatever value you put into this function, we are just going to add 1 to it. So that means with this one, we can say, well, f of 3 is just going to be 3 plus 1, which is 4. Okay, and then f of 10 is just going to be 10 plus 1. So whatever we input to the function, we just add 1 to it. So hopefully you've pressed pause and had a go at this. So that is just going to say, well, whatever we input into this function, we are going to add 6 to it. And whatever we input into the same function, we are just going to add 6. And that gives us 21. So moving on, we are now looking at a very similar kind of example, but this time we have 3x. So what this is saying is, well, whatever you input into this function, we are going to multiply it by 3 and then add 1. Okay, so with this one, we have, well, f of 4 is going to be 3, I'll use brackets here, times 4 plus 1. Now we know 3 times 4, we can write that as 12 plus 1, which is 13. And same with this one. So this has a 7, so that's going to be 3. We'll use brackets again, plus 1, which is 21, plus 1, which is 22. So again, hopefully you've pressed pause and had a go at this. So with this function, we are going to multiply whatever you put in by 4 and add 2 to it. So that would be, we always want to show the full working out, which is why I always write these out. So that becomes 10. And then for this one down here, same thing again, we'll use brackets for the value that's been put in. So that is 4 plus 2, which is 6. So moving on, this is where things get a little bit tricky with negative numbers. You just want to use brackets with these. So I'm just going to look at this one first. So what this is saying is, well, whatever you put into this function, we are going to multiply that by 2, and we're going to take it away from the same number squared. So that means if I write this out, that becomes, it's even more important to use brackets when you have negative numbers. So this becomes minus 4, this becomes negative, and then negative 2 squared is positive 4. So the answer becomes negative 8. With this one, same thing again. We're going to use brackets. It is minus 5 all squared. So this becomes minus 10, minus, and then minus 5 squared becomes 25, which gives you minus 35. So hopefully you've pressed pause and had a go at this one. So with this, again, same thing, just being very careful with the negatives here. There's a negative there. We're going to use brackets for the value of x, minus, again, brackets for the value of x squared. Now this one is tricky. So this bit here is a negative times a negative, so that becomes a positive. So that becomes just 3. And then we have a minus, and then we have a minus 3 squared, which becomes 9. So my final answer here is minus 6. And then down here, if I do the same thing, negative, we're going to use bracket values to put that in. So this bit here becomes a 4. Then we have a negative, 4 squared is 16. And then we are left with minus 12. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers, mark your work. So moving on, we are now looking at composite functions. So composite function, as you can see the difference here, is that this function here, g of x, and we have f of x, and we are putting g of x into f of x, okay? So that is what a composite function is, when you put a function into a function. So the way we write this out is, firstly, we'll use brackets to make our life easier. So I'm going to rewrite the same thing, but with an extra bracket. Okay, so what this is saying is into the function f of x, we are adding g of 5. Well, what is g of 5? When you pass 5 into the function g of x, what do you get? So if I rewrite this again, what I'm saying is I have this f, and this is basically just we're just going to put the 5 in there. So that becomes 5 plus 3, which becomes f of 8. Now we just have this to deal with. Well, that's f of 8. That's just that function there. So that just becomes, well, f of 8 is just going to become 8 plus 1, which is 9. So hopefully you've pressed pause and had a go at the example on the right. So the first step here is just to write the extra bracket for clarity. So we have a function f. Into it, we are putting the function g, and we're passing 2. So we're going to deal with this bit first. So to deal with this bit, we just need to look at that. So that means into the function g, we are putting 2. So that'll be x plus 2. So that'll be 2 plus 2. Now, we know 2 plus 2 is 4. That just leaves us with this now. Now, with this, we just need to put it into there. So that then becomes, well, 4 plus 4, which is 8. So moving on. So we now have f of g of 7 and g of f of 3. I'm just going to do this down here. So we have f of g, again, right in that extra bracket. We're going to deal with the inside first. So the inside is just that bit there. Okay, so that bit, we're going to use this to help us. So that then becomes, well, f of 7 minus 1, which is f of 6. So now I'm just left with f of 6. So I just need to look at this now. So that means it's going to be, well, 3 times 6, which is 18. Okay, so the answer to this one is 18. Now if I just draw a line down the middle to work on the other one. Now we have g of f of 3. So firstly, like before, we're going to deal with the inside first. So here we have f of 3, so we put that into there. So that becomes g of 3 bracket 3, which can then be written as g bracket 9. And now we're putting a 9 into the function g, so that goes into here. So that can be written as, well, 9 minus 1, which is 8. So the answer here is 8. So again, hopefully you've pressed pause and had a go at the example on the right. So we have f of g with the 6 going in there. So if I look at this bit first, that would be this here. So x in our case is 6, so that would be 6 minus 4, which is f of 2. And now if I just look at f of 2, then, well, that's just going to be 2 times 2, which is 4. So the answer here is 4. And then if I look at the other case, which is that one there, if I just draw my line again. So we can rewrite this as, well, solve that first. So that becomes just that. So that would just be g of 2 bracket 1, which is just g of 2. Now we're left with g of 2. So we just need to put 2 into this function here. That becomes, well, 2 minus 4, which is minus 2. So moving on, we now have x squared minus x and x minus 1. So same rule applies again. Let's write this out with that extra bracket for clarity. Well, let's deal with this bit first, nice and easy. Well, that's just going to be 3 minus 1. Now let's deal with this. We're just putting a 2 into this function here. So that becomes, if I use brackets, 2 squared minus 2, which is 4 minus 2, which is 2. So the answer here is 2. If I draw my line again, we now have g of f with the 7. So if I deal with the inside first, I can just put it into there. So that becomes g with 7 squared minus 7. Now I should use the brackets as I say. So that would become g of 49 minus 7, which becomes g of 42. And now we're going to substitute that into g of x. So that is now going to go to there. So that just means it's just going to be 42 minus 1, which is 41. So again, hopefully you've pressed pause and had a that example on the right. So with the first one, we have f of g of 6 So I can write that as, well, we're just going to put 6 into the function g, so that would be 6 minus 5, which is just f1. And now, if I look at the f function, I'm just going to put a 1 in for x, that'll be that. Take away 3 bracket 1, which is just 1, minus 3, which is minus 2. And then if I look at f g of f with 2, so we're going to look at the f function first. So that would become, well, 2 squared minus 3 bracket 2. So that becomes 4 minus 6, which becomes minus 2. And now we're just going to put minus 2 into that g function. So that gives us minus 2 minus 5, which becomes minus 7. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. So we are now looking at proof. So proof questions are normally like, show that this becomes this. So all we need to do is prove that. So I'm going to write exactly that. So we have f of g of x. So we are putting, so well, what is g of x? Let's put this in first. Well, that's just 5x plus 1. So I'm just writing that exact same thing out. And now I've just got to put this into the function f. So this is going to go into this. So that just becomes, well, 5x plus 1. Again, I'll use brackets for the value of x plus 2, which is 5x plus 3. And again, hopefully you've pressed pause and had a good example on the right. So if you focus on that bit there, we have f of g of x, right? We focus on the inside first. Well, what is this? It's that there. So now we just need to put this into the f function, which means this is going to go in there, which then becomes 2x plus 1 plus 3, which is 2x plus 4. So we now have squared in this example. So we have f of g of x. Again, if we start inside first, well, g of x we know is that there. Now I've just got to substitute this into the f function for this and for this. So that is going to become x minus 2 squared plus x minus 2. So that then becomes x squared minus 4x plus 4 plus x minus 2, which then becomes, well, x squared minus 3x plus 2. And over on the right, hopefully you have pressed pause and had a go at this. G of f of x. So what is f of x? That is x plus 1 all squared. Okay. And then we're going to put this into the g function. So that's going to go in there. So that then becomes 2 bracket x plus 1 all squared minus 1. And then that becomes 2 bracket x squared plus 2x plus 1 minus 1. So you can see that just goes, and then we're left with 2 bracket x squared plus 2x. And you can see how that factorizes, so that you can just take the x out. There we go. So here's some practice questions you need to have a go at. Press pause and have a go. Here are the answers. Mark your work. And then finally, we are going to look at solving. So we need to solve f of g of x is equal to g of f of x. So the first step really is to find out, well, what is this and what is this? So f of g of x is what? So in this case, what is g of x? That's x plus 3. And then substitute that into the f. So that will be x plus 3 all squared minus 1. That's x squared plus 6x plus 9 minus 1. Which just becomes, well, we'll just tidy this up, so that just ends up becoming an 8. So we've now found what this is. We now need to find what this is. So we have g of f of x. Well, what is it for x? X squared minus 1. We just substitute that into the g now, so x squared minus 1 plus 3. And we can again tidy that up just here, so that'll just be plus 2. Okay, now we just need to make these two equal to each other. So if I just bring that here, x squared plus 2, and I can see that, and that cancel out. I can see 6x, I can subtract 8 from each side, that becomes minus 6, so I can see that x will just become minus 1. So hopefully you've pressed pause and had a good example on the right. Step 1 is to find this, step 2 is to find this. and then make them equal to each other. So that'll be 100 minus 2 will give you the 98. Awesome. G of f of x and into g. Again, that just becomes plus 8 when we simplify that. So these two are equal to each other. That and that, of course, cancel out. We can move so we can do 8 minus 90. It just gives us the minus 90, so 28. And that'll be a negative 9 over 2. So here's some practice questions for you to have a go at. Press pause and have a go. Here are the answers. Mark your work. And as always, we always wrap with an exam question. Now feel free to press pause and give this a crack yourself before I go through it. But again, it should be very straightforward based on the examples we've done. So step 1, we have g of f of 3. So into the function g, we are going to put f of minus 3. But let's solve this first. It'll make our life easier. So let's put that into there. So that becomes g of, we have 2 bracket minus 3 plus 3, and the whole thing is squared. Okay, so that becomes, well, 2 times that, so that's minus 6 plus 3 all squared, and then that can become minus 3 all squared, which is just 9. So now we just need to put 9 into this function here, and we've solved the question. So that becomes 2 bracket 9 minus 1, which is 18 minus 1, which is 17. So if you would like more practice, I've got a full worksheet over on my website with the answers. Do check it out. If you're interested in one-to-one tutoring, I'll leave a link in the description below. And don't forget to check out all my other content. And as always, I'll catch you in the next one.